you could have put things together that went 45 minutes. I just did a call out, and then we got Michael, and then we ended up doing some collaborative work, and that was kind of fun. So some of the organizers, my name's Sean. This is some of our contact information. Kathleen and John are not here, but Anthony is here. If you want to stand up and just don't be shy. Hey. This is Anthony. If you have any questions or anything like that, you can ask him. Well, and I should have updated this slide beforehand, but anybody here know what Data Community DC is? I know your hand should go up. Oh, that's just a couple people. So we just added a couple of programs. That's why I mentioned that. We added Women Data Scientists DC, and our newest program with Andrew Conklin, formerly called DC Night Owls, is now DC2 Digital Nomads. We'll be sending out some announcements, and we also have Data Science DC, Data Innovation, of course, Data Viz, Data Wranglers, focusing on different parts of data science. And obviously, we do grassroots speaking. So anybody here ever think about giving a talk before? No? Yeah, well, I know you do. I know. Anybody else? Okay. Any thoughts that you've had at some point? Any ideas? Anything that you're proud of? Anything you wish your boss had paid attention to? And then you never got a chance to present it at that big important meeting. Anything? Nobody? Everybody's completely content.
Wonderful, isn't it?
It is wonderful. Anyway, so I love the grassroots side of it.
Sean, do you mind if I steal your audience for a moment?
Well, I mean,
just one quick survey. Who has heard of a digital nomad? Are they familiar with what that is? Okay, cool. That was it. Thank you.
Dangerous.
Watch that go. So, and of course, we digital nomads is going to be focused around some of the projects that help the nonprofit in general, which is what DC2 is. So we have the web apps. I keep pointing at the screen as if you guys can see it. That has to do with some of the web apps. Anybody wants to blog, we have some opportunities there. And teaching is always fun. These things are very, very simple. Sometimes I do something on D3, sometimes I do things on Python. So if you're interested in that, talk to us. And of course, there's all the different types of sponsorship. And we of course have Booz Allen. Everybody here I think knows that Booz Allen is the overall consulting conglomerate that wants to work for every part of the government and every program that there is. Statistics.com is an education partner that we've had for a long time. They have great online courses, and actually we fed some of the teachers that they have. Great opportunity there. And deep learning analytics. John, did you leave?
I'm right here.
There he is.
Wait, can you go back up to the speaker and blog and the previous slide?
This one? Or this one?
So I've done that. I've done that twice for DC Data Community, one for Sean and one for Data Science. I have helped organize events. I've been a sponsor. That's what I'm doing tonight. I've blogged a number of times. So do these things and it'll be better for the community. So I run a company called Deep Learning Analytics. We have a team of 9. We have offices in Roslyn and Ballston, and we do some interesting work for the federal government in deep learning, if anybody's interested or has any appreciation for that. We're hiring, so you can send an email to John K at deeplearninganalytics.com if you're interested. Thanks.
Cool. And if you forget his email, you're always welcome to come through us and I'll redirect you. And of course, the other sponsor is FI Consulting. Derek, Michelle, Don, anybody want to say something?
Director of development here at FI Consulting. We are a consulting firm specialized in data analytics and technology, especially where we can bring them together and where they intersect. We do a lot of work with federal government and also banks and we are also looking to continue to hire people. We are expanding and we just recently had a new office, so we wanted to let it be for the community.
Thank you for hosting us. And thank you for all the great food outside. I know I mentioned statistics.com before. If you use the code GC2 on their site, it's get a nice percentage off. Anybody else have anything that they would like to say?
Hi, I'm Michael. So I run another meetup called Transportation Techies. If you like coming to Roslyn at night to talk about cool tech stuff, especially about buses and transportation, we are literally across the street at 5 minutes from Visit Your Neighbors over at Mobility Lab. It's right around the corner on Oak Street. Our next meetup is November 23rd. It's the Monday before Thanksgiving. I'm hoping to get a guy in a giant turkey costume. Wish me luck. And it should be fun. Just check us out, Transportation Techies. It's so much fun. And we're planning for what's after November? December, to do our bike theme, which is also a lot of fun. We're looking for sponsors for that one.
Any other announcements?
Hello, sort of unofficially. This is my first night here. I'm actually just moved into town. My name's Casey. I work at a digital agency called Agency Chief on DuPont Circle, and they host a number of meetups if you've ever been there. First Tuesday of the month is the API meetup, though, and we get a lot of federal workers there from USDS and 18F. We work on some pretty advanced topics. So look them up on Meetup, and we have a lot of pizza and beer constantly.
I'm surprised I never hit Scott up to sponsor or host an event
What's that for here?
for at Chief.
Yeah, I mean, he's always looking. Like, he's a vacuum of meetups.
I
So
don't know why I never
Yeah.
talked to him about that. Okay, so going on, that consulting. We were going to have beer here, but since we're not, Derek, would you like to suggest the closest watering hole?
Right across the street is Heavy Seas. It's a good place that people typically go to in this area. There's a couple other places that I think that's a great place to have their, they brew their own beer. It's fairly new and people seem to like it.
So if we go out, normally I provide a map. So if we go out the front door, because I think that's
You go out the front door, you
north,
go right out the front door.
and
make a
Target's right there on your right.
You make a right, then make a left on the street that you get to, which
That kind of goes down and winds a little
it's
bit.
right there on Oak. Yeah.
Yeah. Okay. So just out, make a left, and it's right there.
what's the name of it again?
Heavy Seas.
Heavy Seas. That's a. Do they make that beer there?
They do.
The Heavy
Well,
Seas.
They do have their own beer. I don't know if it's that exact thing, but they do their own beer.
So without further ado, I mentioned Max, and he showed me his time series plot, and it's taken me forever to figure out exactly how it is that they work. We've had a number of emails go back and forth about these time maps. It's part of the reason why I wanted to have this event, is because they're kind of compelling, and I've never thought about time series quite like this. So round of applause for Max.
All right, thank you, Sean. Let me just move this so I can face the audience.
I can be the button pusher.
Oh, that's all right. So as Sean said, my name is Max Watson, and I'm a data scientist at L3 Global Solutions, and I'll be talking about a novel way to visualize timestamp data or discrete events. So what I mean by discrete events is any event that's tied to a specific moment in time. So these events are all around us. So they can include mouse button clicks, or online transactions, or even when a dog catches a frisbee, that can be a discrete event also. So who in this audience has discrete event data? Okay, good, good. So the most intuitive way to visualize timestamp data is with a histogram. So this is a histogram over time, and the height of each bar is the number of events that occurred in each bin. So this tells you some overall interesting trends about your data, but all the details about what happens inside each time bin is completely lost because it just says this amount of events happen in this time bin. And you can always re-bin your data and look at a smaller window. For example, you could look at individual days, but then the more you zoom into it, the more stuff you have to inspect. So for instance, if you wanted to look at individual days, this is over 7 months. So then you'd have 210 days to look at. So another way, a kind of less mainstream way to look at discrete events is with these spiral graphs. And so this is basically, the line is like a winding line that spirals out. And so that allows you to stretch out the timeline and see more of it on the page. And so each dot is an event. This also can reveal some patterns, like you see some clustering going on, but it's totally non-quantitative. And when the dots are really close together, you have no idea how many dots are actually there. You just see these black balls of points. So what I'm going to describe is a novel way to look at timestamp data where you can see patterns across all time scales, and you have to do very little zooming in at all. Then I'm going to show some cool examples, some that I made and then also some other people have made. And then finally, I'm going to finish up with some closing remarks. So this was all inspired by a book that is called The Dripping Faucet as a Model Chaotic System, written back in 1984 by Robert Shaw. And Robert Shaw actually won a MacArthur Genius Award for his pioneering work in the field of chaos and dynamic systems. And this is a really great book. I really recommend it. You don't need to know any physics to get it, and it's all about information theory and probability. It's a really cool book. And he has this really great way of visualizing these drops from a water faucet. And these drops are just discrete events. So this is how you make it. So you just represent your events as dots along your time axis. And so each of these is a discrete event. And then you calculate the time differences between all of your individual events. So those are T3, T4, and so on. And then you build a scatter plot based on the neighboring time differences. Those are your X and Y coordinates. So for example, if we're going to plot the red dot on the scatter plot, we just look at the time before it, so that's T4, and then you look at the time after it, that's T5. You take those two things, you take T4, which is the time before it, that's your X coordinate, and then you take the time after it, which is T5, and then that's your Y coordinate. And then you do this for all of the points in your data set. And so that is how you make a time map, basically. So it's gone by different names. If you search for this online, you could probably search for return map or return time map, but I'm just going to call it time map for short. So does anyone have any questions before I go on? Because you need to understand this in order to understand the rest of the talk. So does anyone have any questions before I go on? No? Okay. So here's some simple examples. So on series A, you just have completely regularly spaced points. They're all evenly spaced with each other. And then the time like a single, because the time map just looks like a single dot. So this is a very compact way to represent this very long series. But then in the second sequence, one of the dots was just moved a little bit, and then the resulting time map clearly reflects this change. And this change would be very hard to notice if you're doing another type of visualization like a histogram or something like that. But this time map makes the change very obvious. And time maps are definitely not the most intuitive, so I made this plot to kind of give a sense of how they work. So basically it's divided into quadrants, and I have these titles here that kind of explain where the point should go. So in the lower left, you have, I call that fast and steady, because that's when you have points that are happening at a very even rate, but they're very, it's happening very fast. So that I call that fast and steady. And then in the upper right, I call that slow and steady, because they're still happening at an even rate, but they're more spaced apart. So that's slow and steady. And then in the speeding up one, that's where you have a long time difference followed by a short time difference. So that's kind of like the rate of the events is speeding up. So that's why I call it speeding up. And then the same for the upper left. You have a short time difference followed by a longer time difference. So that's like slowing down. So now I'm going to go over some examples. So one thing that we have access to is information from a bot. So a bot is basically a program that can live on any of our computers that automatically executes tasks online. And so bots are unwittingly installed on millions of computers when users click on shady links. And so it could be just operating from your computer and you wouldn't even know it. So this is a histogram plot of data for a bot that operated from a certain IP address. And so we got this from a company that monitors different traffic to different websites. So this is the time series data for the number of hits across time for a certain bot. And it's the same plot I showed earlier. And you do see certain interesting things in this histogram, but the time map reveals an even more interesting pattern. And so notice that I'm plotting it on a logarithmic scale. And the great thing about this is that you can look at time scales ranging from milliseconds all the way up to months in a single image without any zooming. And so what you see are these interesting clusters. And so in this lower left-hand one, so I call that rapid burst because that's when it's firing very rapidly. It's doing many website hits very close to each other, very rapid pace. Then you have these the kind of sparse points. That's when you have a very long waiting period followed by jumping back into rapid action. So those are the dormant periods between bursts. And you can see that sometimes it's very long, sometimes it's all the way almost up to 4 months. And then finally, you have these bars, which are these correspond to 8-minute lulls between bursts. So this can be confirmed by looking at a really zoomed in version of the histogram. So this is the histogram, but now I'm just plotting it from noon to 1 p.m. And just as we saw from the time map, you see that the bot visits 20 websites and then rests, and then 20 websites and then rests, and 20 websites and rests. And then the distance between each of those bursts are these 8-minute time intervals that we saw in the time map. So the great thing about the time map is that it revealed this behavior in a single image, and we didn't have to do any zooming at all. Because probably you wouldn't have even thought to zoom in to this level to see this pattern. The time map revealed all of it. So for my second example, I use Twitter. So Twitter is really great because it gives you a lot of free data. And you can get, for any single user, you can get their last 3,200 tweets for free. And I use Twython to do this. So that's a version where it's connected to Python. So you don't need to know Java or anything like that. So these are the tweets from Barack Obama, or Barack Obama's team. So in this, every dot is a tweet. And I also color-coded it by the time of day. And so, again, it's on a logarithmic scale, so you can look at what's happening on the minute time scale and then all the way up to the 2-day time scale. And so you see these really interesting patterns. You see ones that correspond to the first tweet of the day, and you can know that it's the first tweet of the day because there's a long period where they didn't do any tweets, where they're asleep, and then suddenly they launch into tweeting every few hours. So you can see that that's the first tweet of the day. You can also see just based on the color coding. And then also on the flip side, there's the last tweet of the day where they're doing many tweets and then they stop tweeting for a long time. They go to sleep. And what's also interesting is that you see the 3 red dots, which are kind of outliers. And those, so 2 of those, I looked those up, actually saw what those tweets were. And so 2 of those were the early morning after the State of the Union address, kind of tweeting about how great the State of the Union is. And then another one is at the very beginning of 2014, celebrating the dawn of the Affordable Care Act. So I thought those are pretty meaningful outliers that just showed up with those red dots. And then since these are very dense clusters, you can also look at a heat map of the data. So this is the same data, and you can still see the individual points. But this way, with the heated time map, it encodes the density of the points too. So the red regions are the very dense regions.
Excuse me.
Yes.
Just to make sure I understand, with regard to time after and time before, after tweet, time before tweet, that's time after and before relative to a 0 point, or the preceding and succeeding tweets?
Yeah, so that's relative to the preceding and succeeding tweets. So you're just looking at the time since the last tweet
Okay.
and the time until the next tweet.
Okay.
Yeah, good question.
The other way I thought of it after talking to Max a bit was you assign every event an X and Y coordinate, where the X is the time to the previous event and the Y is the time to the next event.
Got it.
Yeah.
Got it.
It takes some getting used to, for sure. I totally admit that.
So, well, one question about that slide since we went back to it.
Uh-huh.
It seems like with the 8 minutes between each
Oh.
tweet, or no, it's not tweets anymore. Each do the 8 minute thing.
Uh-huh.
Seems like there should be a slow and steady. Why? One more, I think.
Yeah, why is there not a slow and steady part?
Yeah. Why is there not? Because that's like every 8 minutes. There seems like there should be something along the diagonal there.
Because you never have a time where you do one tweet, where you never have 8 minutes and then one hit and then 8 minutes again. You have 8 minutes and then 20 hits.
Oh, yeah.
And then
yeah,
8 minutes. So there's never a slow and steady one.
It's 20.
Yeah, it's 20 inside there.
Oh, yeah.
Yeah, good question. Okay, and so this is the heated time map. And the great thing about these heated time maps is even if your points, you have so many points that's incredibly dense, even the scatter plot, even if the scatter plot is totally filled, the time map can still reveal the densities. So that's why you want to do the heated time map when you have many, many points. Yeah.
Any idea what that one cluster in the upper right could be?
I don't know, maybe something, I mean, they're kind of higher order clusters, maybe with weekends. Maybe they waited 2 days, something like that. I'm not sure.
Because that would seem like a position where they would regularly do tweets that are days apart.
Yeah, I'm not sure. Maybe they were, I don't know. That's also the great thing. I mean, there are these main clusters, but then there are all these other points that you could just say, hey, what's that? And then you can kind of look at outlier behaviors. Yeah.
So how did you handle if there were more than one before and after that simultaneously occurred, like the web hit thing?
Well, those really weren't simultaneous. They just were very finely, they were separated by less than a second.
Okay. So you've got to get down to a very fine granularity. If there was a burst of, I don't know, 200 web hits after one discrete event, the time after the one event, you'd have to slice down to where you could pick out of the succeeding 250 the one to do the time after measurement.
You could just say it's 0. If your granularity wasn't fine enough, you could just say it's 0.
Okay.
And then you have to slightly modify your logarithmic thing.
Right.
So you can't do the log of 0. Maybe you would kind of artificially set that to 0.1 seconds or something. And then you could still do it on a logarithmic scale.
Okay.
Yeah.
On your graph, I'm assuming that it's 3,200 tweets over the past 2 years, but I don't know for sure.
Well, it depends. Whatever.
Yeah, I'm actually just asking out of curiosity. Do you know what the time scale of the last 300 tweets are?
For that one, it was about 1.5 years for the Barack Obama one. Okay. But if someone's tweeting like nonstop, then it won't go as far back. Yeah. Feel free to ask questions whenever. And so, so this was Barack Obama's or his staff's Twitter behavior, but then you can compare it to someone else's Twitter behavior. So this is real Donald Trump's.
It looks like his hair.
It looks like him, right? And so you can see it's completely different, right? It's very regimented. The Barack Obama staff is very regimented, where Donald Trump's is just all over the place. Okay, so So since I wrote this blog about it on District Data Labs, other people have made time maps on data that I never would have imagined. So now I'm going to talk about those. So this guy, Sean Taylor on Twitter, he works at Facebook, and he made a time map of his yoga visits. And aside from a few lapses, it looks like he's a pretty consistent yoga guy. Wendy Mack made this website, this interactive website, where you can just put in any Twitter handle you want to look at, and then it will generate the heated time map for you. I can give you the info on how to this URL later, but you can do it for any Twitter user. That's pretty cool. It's in D3. So this guy is from the Czech Republic, and he made a time map based on Beatles songs. And so the way that worked is that he found some resource online of MIDI files that says when chords happen in Beatles songs. You think of a chord as just the strum of a guitar, and that's a chord. And so for each individual Beatles song, he found the timings of when the chords happen in each song. So that's what the dots there are, the chords in each song. So he made a time map for each individual song, and then superimposed all the time maps onto a combined time map. You just put them all together. And then he got this really cool time map. He didn't explain like what the units are or what the colors mean, but that's beside the point. Details. But you definitely see some really cool patterns, maybe due to the fact that you have regular tempos, and the time map definitely reveals some interesting patterns in these songs. And finally, Scott Horvath, he also wrote a thing on LinkedIn about what he did. So similarly, he used a similar approach to the Beatles stuff. But this was with call center data, where there are publicly available call center data containing the timings of when people called in to the call center. So here you have data based on customer 1, when they called in the call center, when customer 2 called in, when customer 3 called in, and so on. Then you did the same thing. You just make a time map for each one, and then superimpose them all together. And then since the data was really dense, he made a heated time map of that. And then he got this cool pattern. So this was made in R. And so this is time since the last call, and then time until the next call. And so, in the lower left, you have calls within the same day. And then in the upper right, in the slow and steady, you have people that are calling back every few weeks. So for instance, maybe the people who own the call center might want to look at that data and say, oh, who are these people that are calling us every 3 weeks? Maybe we're not serving them as customers. So this is a nice exploratory method to look at your data from a bird's eye view. So I talked about examples, and so now I'm going to finish up with some closing remarks. Time maps are a tool like any other tool. They have their strengths and weaknesses. There are times when you should use it and times when you shouldn't use it. But the best visualizations and the best analysis will involve a combination of traditional methods like histograms and visualization and new visualizations like time maps, and of course actual mathematical data science also. And so just as a carpenter knows how to use a saw and knows how to use a screwdriver, a good visualizer and a good data scientist should know how to use a histogram and how to use a time map. So the main take-home messages are that time maps can reveal hidden patterns across many time scales. You don't have to zoom in to specific days or specific hours. It kind of shows you everything at once. Heated time maps are completely scalable for your big data needs, because really heated time maps are just based on counts. And so counts are something that big data can certainly handle. I mean, big data being like Hadoop and Spark and MapReduce and things like that. And time maps will be most effective when they're combined with other methods. So when they're used in concert with traditional methods. If you'd like to learn some more, there are a number of resources. So District Data Labs is where the blog is, where I originally talked about this. And there's also some sample Python code to make time maps yourself. It's really easy. It's only a few lines. On Twitter, I've tweeted about it. And also, if you search for time map viz, there are tweets that have time maps in them. And I also urge you all to include that hashtag when you make your own time maps, so that we can, add more to that hashtag. On GitHub, there's more detailed code that includes how to download tweets. So it automatically downloads tweets for you as long as you have your own Twitter credentials. And finally, this was part of an accepted paper to the IEEE Big Data Conference. And so that should be officially published in a few months. And that includes more detailed examples. And I also go into how time maps and probability theory naturally are kind of one and the same. And finally, L3 is hiring data scientists. And if you want an all-in-one big data platform for big data analytics, you should check out our big data ecosystem, or BDE for short. And finally, I'd like to thank Steve Macchio and Rich Hyman for letting me pursue this project. And I'd also like to thank Joe Costantini and Dina Eliezer for helping me along the way. So thank you.
Any questions?
Could you come back a year from now with a meta time map of all the times you used a time map this next 12 months?
If I remember myself. Yeah.
Time map to a time map.
Yeah.
Yeah, why not?
I'm just curious. So before the event, we were talking about his background. He has a PhD in physics, and I said, "Oh, well, what kind of physics?" And normally that's just a quick answer: solid state physics, theoretical physics, nuclear physics, something, right? And so you paused. And I'm like, this is not a trick question. This shouldn't be too difficult. And it turns out that I forget if you said biology or not, but basically you're studying the physics of cell membranes and the proteins that interact with those cell membranes. And what in the world does this have to do with that?
So yeah, nothing. So this chaos stuff is not even part of the standard physics curriculum at all, not even graduate school. This was just something I remembered from a talk I went to just one day years ago. And so I just remembered, I was lying in bed one night. I thought, hey, what about that return map thing? Maybe I should try that out. So that's where it came from.
I always love the twists and turns. One more round of applause. So next up is Michael Eichler. Let's see. Do you have your presentation already loaded up on here? Yep. So, well, you know what? I'll let you pull it up. But you previously worked for Oracle, and then you decide. Did you decide you didn't like it there? Or did you decide you just wanted to do something else?
I wanted to do something real with all the technology that I was playing with.
Okay. And you ended up quitting, and then going back to school at Berkeley, and getting a degree associated with transportation. What was the degree called?
It was a dual master's in transportation engineering and city planning.
Transportation and city planning. Now he works for WMATA, right? So it's literally a path to his dream job. And he emails me after I put out the all hands is that we needed any other presenters, and he points me to their website. And it turns out he's helping the city do exactly what I think data viz should be used for, which is guiding decisions, right? So a lot of times you put up a spreadsheet or something, or maybe even one or two charts in front of people, and you spend a lot of time explaining it, and it's like a joke. If you have to explain it, then it's not funny and nobody's going to get it, right? If you have to spend a lot of time explaining the data, people aren't going to get it. So we had a bit of a, you brought up, right, you brought up mine. So we had a bit of a collaboration, and we took Michael's Metro, is this Metro and bus?
That is just Metro Rail and just entries.
What's Metro? So Michael's, Matt's, mine, and I think this is just.
Mine, that's mine.
Is again,
Sorry, no, Matthew is a colleague of mine.
Matthew,
who
excuse
has
me, Matthew and Max.
a unique travel
Mixed
pattern,
up.
so we pulled these data too.
I don't know who Matthew is.
He's a good guy.
You can tell, he's clearly a good guy. He goes to work, he goes home, he goes to daycare, and he comes back from daycare. And so they go to work and then they come home, they go to work and then they come home. And I have no discernible pattern. I am a freelance data scientist. I have no go to work or come home schedule, so I guess this makes some sense. And so I thought that was kind of fun. So it's kind of a collaboration between the two. So here to present about his dream job is Michael.
Sure, thank you. First off, I come with swag. I have like 80 Metro Rail system map lens cleaning cloths. So you can take, actually there are probably two stuck together. So make sure,
around.
yeah, just go grab one, pass them around. You can have more than one if you want. If you don't even have glasses, they work on iPhones or screens. So, and we have like enough. So help yourself.
This is like extremely practical. This is the best thing I'll get all week.
Yeah. I have like no idea how you. This is like the best thing I've ever gotten.
Yeah, this is. Yeah.
I love making people happy. I love data and I love making people happy.
I'm equally lost and have a dirty phone, so this is.
Like I literally am like working on data on the Metro like every day.
Nice. Can I make this little preview guide bigger? That
I don't know.
little tiny thing. It's so useless, like this little.
Yeah,
you can't even see it. So I'll just look at this stuff. So as Sean, wait, I have second pass. Can we do second pass?
Anybody not get one that wants one?
There's more. Okay, we're good. We're good. All right. Oh, more over there.
I'll collect them in a minute.
All right. So. Okay, we all lens clean for all of our lenses. Okay, so again, my name is Michael Eichler. I'm with WMATA Metro Rail, Metro Bus. Anyone take Metro here today? Does anyone take Metro home after this? Okay, so everyone knows about Metro. Good for you. First off, I just want to say on some level, like, I'm sorry. I'm a Metro Rail rider too. I experience meltdowns all the time. Not all the time, thankfully, but we experience them. We're working on it. We're trying our best, and we're using lots of data to try to solve a lot of these problems. So if you have any ideas, please let us know. But we're trying. But what I'm going to talk to you about today is sort of a hybrid of like what is GTFS and what is Tableau. Does anyone know what GTFS is? Oh, only one. All right. Well. And then what about Tableau? Who's used Tableau before? Okay, so I will gloss over the Tableau stuff and maybe focus a little bit on GTFS. Because I know that as all data nerds like me, sometimes you just run out of data to be nerdy with. And so GTFS is a really cool data source, and you can get it for transit systems around the world, and there's really nothing stopping you. But all right, so outline, yeah, whatever. So we already know about Metro. We now have 91 stations. 300 bus routes, if you can believe that. Anyway, so what is GTFS? It is the Google, General Transit Feed Specification. It was actually developed by Google as a way to standardize the schedule data for transit systems so that they could then show that on their maps. And then, oh, by the way, we'll open up the standard and we'll allow app developers and whoever else wants to use the same data to put that on their maps and their schedules and systems and whatnot. So it's basically like a flat file relational database, which is CSVs that are zipped up together. And this is what the entity relationship diagram looks like. Basically, you've got multiple agencies. Each agency has multiple routes. Each route takes a series of trips that stop at stops in a stop times many-to-many relationship. And then there's these dashed boxes, which I think are either phase 2 or they're not quite there yet, or maybe they're not required. They have some new stuff about fares, which up until recently you couldn't actually represent the Metro Rail fare system in GTFS because it was too complicated. So it's basically the general idea is you have an agency. The agency operates routes. Routes do trips. Those trips stop at stops at specific times, and then you have different types of calendars. You have like a Monday through Thursday, which is one type, and Friday, which is just like Thursday, but it lasts until 3 a.m. instead of stopping at midnight, and then a Saturday. So there are different calendars in there as well. But basically, using this representation, you can describe when metro buses and trains are supposed to stop at different stops around the region. And they also come with shapes, so you can actually map them, which is pretty neat. You can actually put these on a map through their shapes. So what is Tableau? I seem to know, but it's basically a very powerful and user-friendly visualization tool. Drag and drop. The secret, in my mind, to Tableau is do all of your data crunching somewhere else, and then just drop everything right onto the map, and it's amazing. So I won't go too far into that. But so before I go into this mess, which I was told to be nerdy, so I'm going to be a little nerdy, I want to show you what I'm working on, which is this, which is a visualization of our GTFS file for our bus routes. And this reloads properly. I don't know why it's over on the side there.
What size is your window?
Oh, that's a good question. Let's see, will this fix it? Yeah, all right. So basically this visualization is 2 maps, but the second one's hidden because there's nothing to show yet. The first map is basically buses per hour at every bus stop in the region. And you can actually toggle it by hour of day, so you can bump it up to 9 a.m. or see what it looks like at noon, or what does it look like at 5 p.m. And so basically the primary motivation here is, you walk down the street and you see this flag, and it's red, white, and blue, and it says Metro Bus. And there's nothing on the pole, and there's no numbers on it, and you're like, what? Does a bus stop there? And if so, like, when is it going to come next, and where does it go? I have no idea. So this basically is supposed to answer that question. So with this right-hand side tool, left-hand side tool, does anyone want to name a bus stop, or should we just do one out front, or?
16th and Cambia.
You want the number?
No, not the number. I'll do 16th and Cambia. Yeah. All right, that's going to be okay, but not super exciting. I'll find it though.
Judgment all wrapped in.
Yeah, I'm really good at that. I'm just going to sort of guess where Cambia is on this map. I think it's up here somewhere. It's probably even further north. This is Kennedy, but this is probably the whole 26 blocks north of there. So basically, you find a bus stop, and then you click on it, and then it will draw you a map to show you where the bus goes. And so over here again, the dots are sized by buses per hour, the smallest being 1 bus per hour. I'm very sad for you if you're waiting 59 minutes for a bus. All the way up to some stops where buses stop once a minute or more. But then, so basically, on this one side, you can see all the different buses and the frequencies, but that doesn't say where they go. Now over here, you click on one, it tells you where it goes. So I happen to click on the northbound bus stop, but and I'm just using all the built-in tools from Tableau, like the zooming and marquee. I guess I accidentally clicked on an L1 or L2 bus stop, because now here's that one. But you can also, I'll grab some from my neighborhood, which is actually pretty full of, look where I can go from my house. That's pretty cool, right? So I can go downtown. I got the 40s, the S's, the H's going across town. So this sort of, the point of this was actually to make a tool and put it online to show everyone that, hey, you can go places on Metrobus, because Metro Rail Map's really easy, the Metro Bus Map's kind of hard. But I ended up actually convincing people internally to build this into our own website. And that wasn't even my intention. But so now this is gonna be part of the next iteration of the website. So how do you build this in Tableau? Well, anyone have any ideas? You use GTFS. Okay, so GTFS again is this flat file database, and this is sort of a slight version of the watered down version of the ERD, but now it has column names. And so basically, down all across the bottom, if you can't see it, sort of get up on the edge of your seat. But the primary rows that I need to bring back are like a direction and a service ID. So service ID is, like, is it a Tuesday, is it a Thursday? And direction is, are you going outbound or inbound, basically. So those two I had to get from this trip table, because we know that we have routes and trips. So trip has a service and a direction. Then I needed to know for for the bus stops, buses per hour. You got a stop ID, the lat long of the stop, and the bus stop name. Because if you click on a bus stop, you see data about it, but if you don't know which one it is, it doesn't really help you out that much. So get those four here from the stops table, and then you take this many-to-many relationship table and you actually do a group by on it, grabbing basically the last two, the first two characters of the time, which would tell you the hour, because it's in a 24-hour format. And if you ever look at GTFS, actually, you'll find that there are 27 hours in the day, which is a little confusing, but that's because in transit time, we actually end the day around 3 in the morning. So the day actually starts at 4 and ends at 27. So don't get spooked by that if you're playing with this. And then the trip ID, I just did a count on that to find out how many times this trip stopped at this stop during this hour, right? And so it's actually pretty simple. It's just 3 tables and a group by, and you end up pulling the data together to make, where does this go? Oh yeah, what am I doing? Boxes? No? Okay, let me just try that. All right.
Well, that's clear.
No, clear as mud. Apparently I did go forward and I just didn't. Yeah, so then you do all of that and you get those columns, and then this is the Tableau building page, and all of your fields just sort of show up in here as dimensions and measures. And then you just drag your Latin long up to here for columns and rows, and then you can do size and color with the buses per hour, which is this measure here. So you just drag it to there and then drag it to there, and it puts it over here on these different shelves. Then doing the colors, I try to avoid green because red-green color blindness, you want to be friendly to those people. And then the sizing by buses, yeah. So basically it's really simple, and it does the map for you automatically. Everything just falls into place. It took me like 3 minutes to build this. So then what about the next one? Well, the next one is like, for any given bus stop in the entire region, I need to know what buses stop there, and then where else they go beyond the stop that I was just at. So, and I hate finishing sentences with that, but that's the best I can do. So basically, we start with the stop time, then find out all the trips that stop at that stop ID. Then we go back out to the routes that those trips are associated with, then go back to find all the other trips, and then we go back to the stop time and eventually the stop, and we end up with this massive, because for every bus stop in the region, you need a row for every other stop that bus will stop at after. You following me here? Because you have to basically make it so when you click one, you show all of the other stops that same bus stops at. So this thing is huge. When I first uploaded it to Tableau Public, they have a limit of like 10 million rows, and I could only do 1 hour per day because each one of these, but they removed the limit, so now it's actually, I think I've got 6 hours of the day up there. Anyway, so that's what the sort of data logic looks like. And then basically you do it, and it takes 5 minutes, and you get the spinny pinwheel, and then finally this thing happens. And you're like, whoa, what is that? Well, that's basically every single bus route for every hour of the day in the entire region all on one map, which is completely useless. But then you make a dashboard, and you drop your bus stop map on one side, and you drop your route map on the other side, and then you go up to this like worksheet add action. And in this add action, you could basically say, on this map on this side, when I click this thing, I want you to filter the other map by what I just clicked on. So in this case, I'm saying when I click on the stop, I want you to filter the other map and only show the bus stops where it has that stop ID, and that will filter out all the other routes and just show all the routes of the ones that we just clicked on. So it's actually pretty simple. Because this data is so complicated with all these different names and colors and whatever, it took me a while to figure out the right combination of filters to really make it snap. But when I did, it worked, and yeah, I was able to inspire our marketing director to build this into the Womata.com website. So I'm happy about that. Okay, anything else? Yeah, so some notes. Best practices. Always one of my biggest complaints with Tableau or anything else is if you've got multiple graphs and they have different scales on them, even though it's the same data. You got to fix the scale so that no matter what, no matter what the data is, it's always the same scale, so you can actually compare easily between maps. I avoid red-green gradients. Transform your data in the underlying data source first. Tableau is powerful, but why make it do work that it's really best suited for. Tableau, it's really easy to get to 80% done with 20% of the work, but you really need to spend that extra 80% of the time to make it really useful and usable. And I learned that the hard way with this is 16 iterations and whatnot. But yeah, so doing tooltips, labels, color that works, instructive text, etc. Limitations, Tableau can really only show like one thing per map or per visualization. You can't have like a series of lines and then overlay that with a series of dots. The lines have to be on one, and the dots have to be on the other. And it'd be nice if you could match those two up, but you can't. And then the layout sort of has this layout wizard, and you drop things around and they shift, but sometimes you feel like you're herding cats trying to get things to lay out correctly. But as I mentioned, we have a lot of data, and we want data nerds to look at it and see what they can find in it. Some of the data that we have includes GCFS bus and rail schedules. We have the 2014 Metro Bus Survey. It's currently online. You can download and read about do analysis of ridership by route, by time of day. And then we also have the 2012 Rail Survey online. And we also continually updating our website, our blog, with big chunks of rail ridership data, origin, destination, by time period, so you can really dig into how people use the Metro rail system. And we've had some really interesting analysis done of it for us that's sort of, oh, we didn't know about that. No, look at that. So if you want to do any analysis, you can go to planetmetro.com, not planet like the planet Earth, but planet like the command, planetmetro.com/data, and that's basically all of our different data downloads and visualizations are available on there. And with that, I'm going to be quiet and see if anyone has any questions. Yeah.
A bullet point on your preceding slide said transform the underlying data,
right,
or transform the data. What does that mean? Entail?
Sure. Well, in this case, as you saw from my crazy entity relationship diagrams, I needed to include data from 3 different tables on one map. I didn't do this in Tableau. I think you can do it in Tableau. You can like write a SQL statement in Tableau, but it's so much easier to just do it in Oracle in this case, and then have Tableau read the view, because create a view that's basically an encapsulated query in Oracle, and then Tableau doesn't care what data, whether they're coming from one table or 5. So keep all the logic in one central place, basically. And in this case, it's the data source. So if you were in Excel, for example, you could do this in Excel. You could have one workbook, one worksheet for each of the different tables. And then you could basically make another sheet that's a query that pulls the data back. And I would rather pull that back and then hit Tableau against that one, instead of trying to join stuff together in Tableau. Mm-hmm. So like the calculation of buses per hour, I had to do a count on a many-to-many relationship. I don't know how Tableau would do that, or if it would do it well, or if it would do it quickly. But I know Oracle, it's what it's made for.
And was this one load of data that then you're pushing up to the website? It's not a continuous stream.
Right. Well, GTFS is schedule data. It doesn't change very often.
Okay.
Our schedules change every 3 months. So it's pretty easy to make a schedule. And actually, this data is about 6 months old.
So you would know when to re-push it?
Yes.
Manually.
Yeah. In this case, you'd know when to refresh it. Yeah.
Okay. Thank you.
Yeah, sure.
Yeah. Well, thank you for coming tonight.
Sure.
I guess my question is, how do you take data like this and take it to management and say, we have something that's actionable here?
It's a good question. In this case, I showed this to my team leader, and he said, actually, in this, what's really happening here is that, so somehow I got away with starting a blog for planning, and so some people in marketing or customer service or communications have tried to sort of make it go away, because it's too many messages being sent by the same agency at the same time. It's hard for them to do their jobs. But somehow it's still up and still running. And I wrote a blog post about this visualization that I built. And then when the editor who's in communications saw it, he wanted me to present it to the whole communications department and just brainstorm how we could be using something like this. But I would say the short answer is, if you build something and it's compelling, it will sell itself. And then
So does the Planet Metro data set include live data?
No. No, we don't have any live data streams.
Do you track that? Do you track actuals versus your schedule?
Yes. We collect that into our key performance indicators of on-time performance, and And if you look at them lately, the numbers are going down, 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 down. And again, I apologize. We're doing the best we can.
That's Metro Rail.
And bus.
Oh, good.
Sorry. And I'll just, so there was a question in this region, yeah?
So, Google now has the bus schedules on it. Is that from this GTFS?
Yep.
So does this system also capture Metro alerts? Because they don't seem to push through anything about the Metro.
Okay.
No, it wouldn't.
This is just for looking at the bus routes and where they exist. All right, I am not an advertiser. I'm not being paid for this. There is an app called City Mapper.
Yeah, that's great.
And it mashes schedule and actual and alerts all into one screen. And it's the best thing ever. I think it's $2. It's the best $2 you'll ever spend. So there you go, City Mapper.
City Mapper.
Yeah, in the back.
Yes. I was just going to ask you if you had an opportunity to use any of the data to visualize system performance. So as you mentioned, like on-time performance or safety performance, see an opportunity to use that kind of data, visualize that data to kind of pinpoint where some problems you might lie. And even thinking about like the time map presentation from before, like, you know, it seems like you could use some performance data in that sort of way where, you know, the regular sort of delivery of the service is important, and you could use a time map to start looking where, you know, maybe we've got bunching or maybe we've got spreading or something like that.
Yeah, I've personally used a lot of our buses as they're rolling through wherever they're leaving a trail of GPS breadcrumbs behind them every 30 seconds. And so we have access to that data, and we can mash it up and take a look at average run times and dwell times, stop frequencies, bunching, whether an improvement actually made a drastic change to the bunching or the frequency or whatever. On the rail side of things, I've been trying our hardest to find some correlation between when we started doing our rebuilding campaign and when on-time performance started getting better. Unfortunately, it seems like the needles are going in the opposite direction. But we're trying to find, so we're doing a lot of stuff. We're trying to do more. Right now, myself and a colleague are sort of our fledgling sort of data to policy analyst types. And there's only 2 of us. And I think we're doing a good job of making our value known to the agency, and maybe we'll get some more staff at some point. We're also outsourcing some of this work to other data viz companies and modeling companies. That we have someone right now that's actually taking a year's worth of tap-ins, tap-outs, and train positions, and they're building a model of where everyone has ever been and what train they got on and how long it took them and when they got off. And then from that, you can say, all right, well, on this rail car, how many people were on it? 105. Whoa, that's pretty crowded. What about the day before? 115. Oh, that's really crowded. So we are doing a lot of stuff. We have an awareness of the power that's in this, and we're trying to use it as much as possible to make things better. So you already talked to you. Anyone else in the back before I go back to our lady in purple? Yeah, Mike?
So GTFS is standard, so have you started playing with other GTFS systems, specifically that are in the DC system, so you can kind of see all the 26 agencies that run the DC?
No. But you're welcome to go to the Tableau website and download my viz and then grab somebody else's GTFS file and put them together. And in the back?
Yeah, so kind of following on that, I know GTFS is a standard, but it occurs to me, I wonder, has anyone looked at taking the same data and actually putting it into a graph database that is a little bit more oriented around kind of route mapping and route planning?
You mean other than Google? Like, what do you mean by, I mean, graph means like X, Y axis, but it also means like network flow stuff. So
yeah, network flow. I'm more on the database side, not on the
I don't know. Drop me a line and I'll let you do it. Right, it's about crowdsourcing. And then in the purple, did you have another comment?
Yeah. Are you getting like a massive amount of data from smart trip cards?
Yes.
Do you have access to that?
Yes.
Okay, anonymized, or for example, the first, the heat slides were like,
I gave it to him. He didn't creepily email it to me.
Yeah. Well, theoretically, you could.
Well,
you have
okay. So we have this thing called Smart Trip registration, and you can go online at smarttrip.wamada.com, and if you haven't done so yet, please do it, because if you lose your Smart Trip card, you lose your balance unless you have it registered, in which case you can transfer the balance to another card. I don't know why we don't do a good job of communicating that to our customers, so I'm doing it now. When you get home, smarttrip.wamada.com, the password requires like multiple exclamation points or something, but it's worth it. Write it down on a sticky, because it's not that, I don't know why our password are so insane. But anyway, so yeah, so if you register your Smart Trip card, then we have one database over here of names and IDs, and we have another database over here of IDs and trip behavior. Okay. So I have access to the second one. Okay. I do not have access to the first one. So if you read to me the number off the back of your card, I could query up multiple years of your ridership history. But I would need to know that it was yours, right? Yeah. I mean, right now I'm looking at like multiple, like 5-6 million different cards in the system. Each one is making multiple trips per day, per month, per year. So being able to pick out any one person from that sea is mind blowing.
Well, in terms of, you mentioned that you would, I think you said one of the projects you would outsource was where they were at, they were looking at load data.
Yes.
Is that coming from the Smart Trip cards database? Okay.
Yes. So they're taking Smart Trip, origin, destination by time, right? And so then they basically say which train did they get on? Right. Because we know where they're going and we know where their trains were because we have all the train movement data. And it assigns passengers to trains, and then they arrive through the system, and then, oops, there's a sick passenger. They have to wait 10 minutes. And so it actually knows the train had to wait here for a certain number of minutes, and then it exited over here. And so it's just the whole logic flow. And it'll be really important for us to better understand crowding on platforms, crowding on trains, how long it really takes people to move through the system versus how much we think it might take. So,
and you also have that for bus data, since that's also Smart Trip now.
Yes, but buses, we don't have exits. The cool thing about the train is that we have the entry and exits, so we know where you got on, we know you got off, and we know how long it took. With the bus, which we have to just guess.
Yeah. Thank you.
Yeah, sure.
I was just wondering on your trains for your cars, how are you getting your density for the car? Are you just assuming an even distribution?
No, we have counters, we have humans. If you're ever on the platform in the middle of the morning and there's like a bunch of people hanging out with clipboards, they're actually working, and they're writing down how many people are on each rail car. Okay. And they're like really well trained, and like they can just blink and 125. I don't know how they do it, but they've been doing it for a while. So we use that data to look at what the distribution of crowding is across the train. It's different for 6s than for 8s.
Yes.
Sadly, the last two, the 7 and the 8, are hardly ever full. So if you're ever on a crowded platform and you want to get to where you're going, and the next train is an 8, go to the end of the platform and get on the 8th train or 8th car, because you'll get to see it. Yeah, so we do a lot of pre-work to go into actually how the loads pan out, and then we apply those to the model to distribute the riders for the trains. We're doing a lot of really cool stuff with data. So if I stumble on any more,
I'm curious. I want to know when it's going to be a virtual reality app, so I can stand there at the bus stop and go like this and see where the bus is going to end up.
When are you going to build it? All the data is open. It's all publicly available. Is anyone using VRML anymore? Is that a thing?
Do you guys have a sponsorship budget? That sounds like a good DC2 Digital Nomads project.
Let's be in touch about Digital Nomads, because we have a series of apps that we want to get built, but we don't know who's going to build them.
Yeah, that's one of our goals, is to take this cool data and make it. It's usable. It's going to be local. We want to make it usable. We want to have people around that know about the data set so they can help other people. Sure. It's supposed to, apply any work that's done, either goes to a nonprofit or goes to somebody in the area that affects everybody's life.
We actually have an RFQ out right now for a consultant to actually host like a hackathon for our data set. So we should be in touch.
Well, yeah. I mean, if I meet anybody like that, I'll for sure help. That made me completely lose whatever it is I was going to.
Sorry.
Is there a Josh Oretsky in the? No, Josh is not here. Okay. So, any other questions?
Anyone else need a lens cleaning cloth?
I'll take two more.
Yeah, these are high commodities. I'll definitely take a second one. Yeah. My girlfriend will want one for sure.
And I've also got cards.
Thank you so much.
Excellent, thank you.
And there's plenty of food. Again, save